So this is that practice one that I gave you. It's just for you to check your answers. All right, I just came back from the dentist, so my voice might not be the best. All right, so let's take a look at your practice. Find a constant proportionality. In order to do that, you have to, first of all, the line has to be show a proportional relationship, and the way you check that, if it's a straight line, which it is, and it goes through 0, 0. So this line represents a proportional relationship. Now, to find constant proportionality, you take any point on that line, and let's take this point over here, and that point is 50, 75. Let me create an XY table. So that point over here, like I said, is 50, 75. This point over here is 40, 60. And this one is 30, 45. This one is 20, 30. So again, you didn't need to write all of these, okay? The unit rate is where 1 and whatever meets, right? 1. So it's 1 with whatever y value. And we can't see that. It's somewhere around here, right? This point right here, but I don't know what the value is. And we can find that out very easily. So let's pick one of these points. All right, and remember, to find the constant proportionalities, k equals y over x. Let's pick this point right here. So it's 75 over 50, which we can simplify to 1.5. 1.5, 1.5, however you want to write it, okay? Or 1.5, or 3 over 2, whichever, or, whatever makes you feel like it's the easier one for you. So that's the constant proportionality. Now, what's the unit rate? Well, if we write this as a fraction, we're going to write that its total cost is, and let's take that point, $75, right? This point right here says that when it's $75, how much square feet of carpet do we use? We use 50 square feet. The unit rate is what's 1 square foot, right? So, and this is the value that we're missing. And what's the price? Well, we found the constant proportionality. Well, this number here is the same as the unit rate, so it's $1.50 per square foot. So now if you think about it, for every x value that's here, we multiply that by 150, we get our y value. So 50 times 1.5 is 75, 40 times 1.5 is 60, 30 times 1.5 is 45. So that is our constant proportionality, right? And which also happens to be our unit rate. So right here, this point right here, where xy, where x equals 1, the y value would be $1.50. So when you have 1 square foot of carpet, you would pay $1.50. That's what that means. What's the equation of the graph? Well, if it's a proportional graph, it comes in this format. Y equals, and k we just found out, it's $1.50, x. So like I was telling you before, every x value is being multiplied by 150. 2. Find the slope. Right, so in this case, it's not a proportional graph, as you can tell, right? Straight line, yes, linear, but it doesn't go through 0, 0. So you can write, no, it's not proportional. Because it does not go through the origin, right? Even though it's a straight line. Find the slope. Well, to find the slope, we pick any 2 points. So let's put some points here. This is 12 and 5. This point is 9 and 4. This point is 6 and 3. No, 6 and 3. Right, and this point is 3 and 2. Pick a pair. Now let's just pick 3 and 2, 6 and 3. Okay? Make one of them your x1, y1, the other one your x2, y2. And let's find the slope. So the slope is change in y values, y2 minus y1 over x2 minus x1. So you're going to get 3 minus 2 over 6 minus 3, and that's just 1 over 2, so that's a half. So that's my slope. And the y-intercept, we can visually see that the y-intercept, so this line goes through the y-axis, and it crosses the y-axis at 1. So your equation line is y equals mx plus b, y equals m, the slope we just found, which is a half, and it's plus b because obviously it's crossing the y-axis at positive 1, and there is your equation line. So the y-intercept, by the way, is 0, 1, right? That's where it crosses the y. So this actually becomes the answer for D. Describe a real-life scenario that would explain 0 and 20. Actually, this should not be. This should actually be 0 and 1, right? Because when x is 0, y is 1. So, how do you explain that you haven't played any golf yet, and you are already one round on par? Maybe this was yesterday's round, okay, and it continues, it's cumulative. So you're starting today's round, and you already have one round at a par. Actually, it doesn't make too much sense, but I think it would have been better if this was like, let's say, tickets, and this would have been price that you spent. So how do you explain that? I bought 0 tickets and I spent $1. Maybe that was the entry fee for the park. Okay. Right. So I won't give, when you're taking the quiz, I won't give you a relationship. It's a little bit weird. Okay. All right. Next one. Which equation represents a proportional relationship? Well, if it represents a proportional relationship, the equation should be in this format: y equals kx. There shouldn't be, well, it's not that there is no y-intercept, right? But it's plus 0 because it goes through the origin. So, but we usually don't write that. So the only one that looks that way, in this case actually, this one is proportional. Oops. And this one's proportional. Okay. Notice that the x is in the denominator, not in the numerator, right? So this is not, and this is not. Oh, actually, yeah, and that's not. Okay, so this one, another way to write this one is 1/3 of x. Okay. Again, you might want to start labeling your graph. So Sue worked 13 hours and earned 156. So we can say that the total earned, the amount she earned, depends on the hours she works, right? So, which means this guy's my dependent variable, and that goes over here, total earned. And the hours may be my independent, which is my x. So let's get some values in here. So 13 hours. Let's go by ones, I guess. So this is 0, 1 hour, 2 hours, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 hours. She made 156 hours. $56. Ugh. Give me a second. Let's do this. Let's find the constant proportionality. So I have a point there, 13 and 56. Right? Obviously, she makes the same amount of money per hour, so that's a constant relationship. So if we do 13 and 156, we can use that point to find k, our constant proportionality, y over x, and we're going to do 156 divided by 13. So that means that per hour, if you think about it, 156 divided by 13, she makes $12 an hour. So k, our constant proportionality, is 12. So that means that every hour she makes $12. So our equation on the line comes in this format: y equals k times x, or in this case, y equals 12 times however many hours she works. So it goes by, so I'm going to make the y interval here by 12. So this is going to be 12, 24, 36, 48, 60, 72, what is this, 84, can I reach 156? Oh my god, 84, 96. 108, 120, and then this is going to be 132. Okay, so I'm just going to extend this a little bit. 120, 132, 144, and then 156. So I'm just going to imagine this, and here's my point. So there's the point. 13 hours, she makes $156. Let me get a we could draw a line. It's going to go through that point. Just move it. There. So this is my equation. Y equals 12 times x, right? So if you look at your graph, 1 hour she makes $12, 2 hours she makes 24, 3 hours, right? It matches. 3 hours 36, 4 hours she makes 48, and so forth. And 13 hours over here, she makes $156. So identify the unit rate on the graph. So on the graph, right here, that's my unit rate, right? This one we're comparing to 1. So this says that in 1 hour, she makes $12. Okay, is the 0.22308 on the line? So meaning, if she works 22 hours, does she really make $308? If that is true, then that 0.22308 should be on the line, not on top of the line. So one way to check that is to use our equation. Our equation is y equals 12x. This is saying that when she works 22 hours, she makes $308. Well, let's see if that's true. So y, so she makes $308 when she works 22 hours. So it's 12 times 22 hours. Well, let's multiply 12 times 22. 12 times 22 is $260. $64, which is definitely not equal to 308. So 0.22 and 308 is not on the line. Okay, so I'm making this up, but it'd be not on top of the line, right? It doesn't, that doesn't follow. It doesn't follow what we have here, where every hour is multiplied by 2, by 12. So this point is not on the line. Okay. All right, so now the easy part, right? So we have a red velvet cake. So red, we use 2/3 spoons of red food coloring. And for every time we use that, we use 3/5 of vanilla. Right, and then a combined total of tablespoons. So if we add 2/3 plus 3/5, you get 1 and 4/15. Right, so right now, with this ratio that's given to us, we have a total of 1 tablespoon and 4/15 of the next. Now they're saying that, right, that's the ratio that we use, but what happens when I use 38 total spoons? Right, so if I increase my recipe here, right, to 38 total spoons, I obviously have to proportionally increase the number of vanilla tablespoons and red tablespoons. So what are we increasing by what factor? So 1 and 1/14, so times what number equals 38? So all we have to do is divide. 38 divided by 1 and 4/15. That's going to give us 30. So it increased by a factor of 30. So everything's going to increase by a factor of 30. 2/3 times 30 is 20. And 3/5 of 30 is 18. Notice that this column here, when you add, it gives you 18. It gives you 38 as well. So that's one way of checking to see that you're correct. Okay, so the answer to this question was, if a total of 38 tablespoons were used, combined with those products, of the two products, 20 of it was red food coloring and 18 was tablespoons of vanilla. Now 6 is just a comparison, right? We want to write it as a unit rate and compare. So it says find the unit rate per hour. So hours is going to go at the bottom. So first try 8.5 miles, 2 hours and 10/60. And now write the unit. So let's change that to unit rate. Find out what her speed was in the first try in Sam in 1 hour. So how much does she run in 1 hour? And then we're going to do Tim. Tim ran 5 3/4 miles in an hour and 25 minutes, or 25 or 60. So as it is right now, right, it's so hard to compare. I don't know who's faster, Sam or Tim, but if I change both of them to the same, right, to 1 hour and 1 hour, I can easily compare. So you have a calculator, so how do we get from here to here? How do I change 2 and 10 over 60 to 1 hour? Well, we divide by 2 and 1/6. I'm just going to, well, it doesn't matter. I'll just keep it like this. And I'm going to repeat the same process on top, right? It's like finding the constant proportionality, right? So 8.5. 8.5 divided by, what is that? 2 and 10 over 60, or 1/6. And we're going to simplify. That means that Sam in 1 hour runs 3 12 and 13th of a mile in 1 hour. Okay. Now Tim, same thing. Let's change that to unit rate. So we're going to divide by 1 and 25 over 60, and we're going to repeat the process here. Divide by 1, 25 over 60. So we're going to get 5 3/4 divided by 1 and 25 over 60, right? Which is 4 and 1 over 17th miles. So now you can clearly compare, because now I know that Sam runs this much in 1 hour and Tim runs this much in 1 hour. Who is the faster person? Well, without a doubt, Tim is. Okay. Alyssa runs 2 3/4 of a mile in 28 minutes and 40 seconds. What is her unit rate in miles per minute? So we want miles on top and minutes at the bottom. So let's write that 2 3/4 miles in 28 minutes and 40 over 60, right? That's what you're going to write. That's how we write. Okay, 28 and 40 over 60, or 40 seconds is 2/3 of a minute, right? So you can do that. I'm going to change this to unit rate of 1 minute. So how much does she run 1 minute? Let's go through the process, right? So we're going to divide top and bottom. This is just like finding constant proportionality, right? K over x, y over x. So we're going to divide by 28 and 2/3 and 28 and 2/3, which is the same thing as 40 over 60. So 2 3/4 divided by 28. Oops. Hang on a second. 28 and 2/3, enter, is 33 over 344 of a mile in 1 minute, which is really slow. No, actually she's not. So how much can she run in 3 minutes? Well, let's add one more over here. So now from 1 minute, we're going to go 3 minutes. Right? So how does that change go? Now how does the 1 become a 3? Well, it's by a factor of 3, right? Times 3. So I'm going to multiply the top times 3. So final answer is 99 over 344 of a mile in 3 minutes. So Bird can type 945 words in 12 minutes. Assume that she can type at a constant rate. So we know already that it's so her rate would be, if we on a graph, would be represented by this line, right? Going from 0, 0, going through the origin, straight line. Assume that she can assume that she can type at a constant rate. Write an equation to determine the number of words W for any number of minutes M. So that's basically saying this, right? Here's the equation. So where this is W, the total number of words, our output, and X is our minutes. So instead of y and x, I use w and m. Big deal, right? So, and we need to just find this, right? The constant proportionality, the unit rate, if you want. So if you write 945 words in 12 minutes, right? So if you were to change this to 1 minute, you would divide by 12. You're going to divide by 12 on top, right? 945 divided by 12 gives you 78.75 words. So remember, the unit rate is also your constant proportionality, so we just found it. So that means that to find the number of words, you're going to multiply 78.75 times the number of minutes. 1 minute is 78.75. 2 minutes would be 78.75 times 2, and so on and so on. Okay. 9. Oops. 9 is, what does 9 say? Tell whether the proportional relationship, tell whether the relationship is proportional, relationship in each table. Explain why or why not. Okay. So let's do this one. So again, we have 1, 2, 3, 4 points, right? 121, 11, 81, 9, 64, 8, 49, 7. So if you did this for each of these points, you should get the same constant proportionality. So in other words, whatever I'm doing to x to get to y, it's the same for 81 and 9, the same for 64 and 8, and 49 and 7. Well, I mean, so the way I would prove it, I would take the first one. Well, the first one would be 11 over 121, right? This is my y value, my x value, so 1121. So let me write k would be 11 over 121. The second one will be 9 over 81. The third one would be 8 over 64. And the last one would be 7 out of 49. Now, if you took a moment and simplified, let's simplify 7 over 49, that would be 1 over 7. Yeah? If you simplify 8 over 64, it would be 1 over 8. Simplify 9 over 81 would be 9 over 1 over 9. So you don't, we can, and there's your proof. Not the same, not the same. So this is not a proportional relationship, right? The constant proportionality for each of these points is different. Okay, so not proportional relationship. Now here, how are we going from 0? So right off the bat, you can say that this is not a proportional relationship because look at your first point, 0, 6. So if you had a graph and you were to plot 0, 6, I mean this is 0 on the x-axis and this is y, 0, 6 would be right here. 0 on the x and 6 on the y. So here's your point 0, 6. The next point, 3, 9. So let's 1, 2, 3, and then let's just imagine 9 over here somewhere. It'll be over here. If you were to connect these points, and then 6 and 12, whatever now, if you were to connect this point, it might be linear. I mean, I'm not graphing the whole thing, but even if it's a straight line, does it go through the orange? No. Right, so there's proof to you right there that this is not a proportional relationship because right there, this point right here tells you it's not. But if you want to the constant proportionality, how is a 3 becoming a 9 times 3? How is a 6 becoming a 12 times 2? And you can already tell that the constant proportionality is not the same. Okay, so I would take the easy route. Use this point right here to tell me, or right, tell you that it's because it's not 0, 0. It's not a proportional because if it was proportional, it would go through 0, 0. So we have an equation of the line, right, which is a straight line according to this, and you have a y-intercept of 4. So 1, 2, 3, 4. And there's a line that's positive, by the way, in this cross. Now there are, on this line, they're asking you, is 0, 0 on this, is 0, 0? Obviously 0, 0 is not on this line. You can clearly tell. It's 2 and 14. So if I go 1, 2, is 2 and 14 on top of this line? It's 9 and 49 on top of the line? You have to prove it. So let's prove it algebraic. So let's take our equation, y equals 5x plus 4. If I take the point 0, 0, if I take the point 0, 0, where, substitute, this equation will be true. Well, they're telling me that y is 0, so I'm going to take this and put a 0. For x is 0, right? So 5 times 0 plus 4. Well, 5 times 0 is 0 plus 4 is 4. So 0 equals 4. Is that true? No. So that proves you that 0, 0 is not on the graph. And we already knew that. because we saw it visually. Second point, 2 and 14. So y equals 5x plus 4. Let's plug in 2 and 14. So 14, I'm going to put it for my x. And 2, I'm going to put it for my, 14, I'm going to put it for my y. And I'm going to plug in 2 for my x. 14 equals 5 times 2 is 10 plus 4 is 14. Is that true? Yes, it is. So 2 and 14 would be on the graph. That point would be on the line. Sorry, not on the graph, on the line. So this one it is. Last one, 9 and 49. Well, this is my x and this is my y value. So let's plug it in the equation. So when y is 49 and x equals 9, right? So 5 times 9 plus 4. 5 times 9 is 45 plus 4 is 49. So that point at 9 and 49 would also be on the graph. Okay? So double check your work. If you have questions, please come see me. I really want you to be ready for taking this quiz. Okay?